Our lesson today is called Multiplying Binomials, which we've already done, but there's some special cases. So let's just review multiplying binomials, what that looks like. Here's an example of a binomial multiplied to another binomial would look something like this. And we have to do the distributive property, or FOIL is the term that we use for multiplying binomials. First, outer, inner, and last. And then we look to combine the like terms, our like terms from our outer and our inner. And we've multiplied the binomial. Now, today there's some special cases. And so this first special case we'll look at is what happens if I had a binomial that was multiplying by itself. So x plus 5 times x plus 5 for an example here. Well, you're probably not going to see it written like this if something is multiplied by itself. Typically, when something is multiplied by itself, it means it is squared. So this is what the problem will look like, and we'll need to figure out what that is. So let's explore what that situation might look like. So let's say I had to do x plus 5 squared. Like, what are we supposed to do? We're supposed to multiply this, and the way to do that is to actually think about what does this mean if it's being squared. It means the squared means it's multiplying by itself. So my first step is to write it like this. Then from there, I can just do my FOIL. First, outer, inner, and last. Now, what we'll see happening here is, notice in the inside here, it's 5x and 5x. They're the same values here, but that makes sense because there are both 5s in each of these quantities. So in here, it becomes 10x plus 25. Now, we want to see a pattern here of what's happening that maybe we could just do a shortcut. So I want to look at these numbers here. We, of course, could always FOIL it out, but maybe some of you will see this kind of pattern of where these numbers came from the original problem up here. So what I see is it's 10x in the middle, and that's because it's from the 5, and then there would be another parenthesis of 5. They add together. 5 plus 5 is 10. Or it's this number doubled would be the idea, is this number. And then the 25 comes from the 5 being squared. So, for example, if I was to do another one, technically I should do this. I recommend doing this and foiling it all out. But if I was to just jump to the end, maybe you can guess what the answer would look like at the end for your trinomial here. The first term would be x squared. The second term is this number times the x doubled. So 9 times x doubled would be 18x, because it would be 9x plus 9x in the middle. And then the last term here would be this number squared, 81. And that's kind of following that pattern. So that's a little bit of a shortcut we have to do here. Now let's just pretend, for example, it is let's actually do something tricky here. Let's say it's just letters, a plus b squared. Of course, we could, the best thing to do would be to understand that this is times itself, but maybe if we can see that like pattern of what we get, it would be a times a is a squared, and then this times this doubled, a times b doubled, would be ab doubled. I'd have to put times 2. That's what was happening here. It's like 2 times of this, 9 and x, 2 of those becomes 18. And lastly here would be this number squared, so b squared. And that's like kind of our official setup formula for any a and b that you plug in there. What if it was x minus 5? Let's say we had to do x minus 5. Well, then I would do x minus 5 times itself. And that I can do FOIL with that. X first is x squared. Outer would be minus 5x. Inner would be minus 5x. And last would be plus 25, because negative times negative. I would combine the like terms. And we see really the same pattern happening. It's just that it's a minus. So when you do the middle term here, it's minus 5x, so that makes negative 10. You're adding them basically together. But then the last becomes positive because it's a negative 5 times a negative 5. So that's why that's positive. So I guess I could, maybe do another example here. Let's say it was like x minus 6 squared, and just go right to the answer if you can catch the pattern. Again, you could always go back and FOIL it out, but if I catch the pattern, it would be minus 6x doubled would be minus 12x. And then minus 6, when it gets squared, becomes a positive 36. So I just went with the shortcut. And then if I just did this as generic a and b, a minus b squared, then when I do this in the formula, it would be first the a squared, then this and this doubled. So a negative ab, these two together doubled would be negative 2ab. And then last would be the negative b squared. When it gets squared, it becomes positive. It follows that pattern. If you want to FOIL it out, go ahead and FOIL it out. But this is another very important kind of discovery. Now, one other idea that we have here, which is, let's say it's not squared. This is a different scenario. Watch this. If it's x, let's say x plus 10, x minus 10. This, notice, I'm giving you the situation where these numbers are the same, but one's positive and one's negative. I could have put the positive here and the negative here. It doesn't matter. But the idea is these are exactly the same, but one of them's positive, one of them's negative. This would be called the difference of squares here. I guess that's what we call it. Foiled out, but yeah, we can call it that. A product of a difference here. So the one's positive, one is negative. But let's just see what happens when it's FOILed. So x times x is x squared first. Outer, negative 10x. Inner, positive 10x. And last is a positive times a negative 10. That makes a negative 100. When I combine the like terms in the inside here, I got, negative 10x plus 10x would make 0 right in the middle. I'm not even going to write anything because they would just cancel each other out, and I get just the minus 100. So it is the trinomial like we had up above in all of these. The difference is that in the middle, they canceled out, and that middle term just was 0. And that's going to happen as long as one is plus and one of them is minus. So if I was to do another example, we could potentially, this is a really important idea for using maybe a shortcut, especially if you're advanced, then you can just, not FOIL here. You would go right to the shortcut. You'd get x squared. The middle terms will cancel out. Minus 7x plus 7x will cancel out. And last would be minus 7 times 7 is a negative number, negative 49. We just go right to the answer a little bit quicker. So that is a nice situation when one of them's positive, one of them's negative. But again, it's got to be the exact same number in order to cancel out. All right, let's say it was generic A and B values, but notice they're exactly the same except one's negative, one's positive. Then your final answer, you could FOIL it for sure to check, but the shortcut would be the middle terms will cancel out. It'll be plus AB minus AB. They'll cancel out, leaving you at the end with B times B, but one is a negative B, one of them is a positive B. So when they multiply, you get a negative B squared, and you get this as your answer there. Let me put these into the note sheet now, what we've discovered. So A plus B squared, we took a look at that. The first thing I want you to write down is that that really means A plus B times itself. But here is the shortcut formula, which I technically don't use this, but I like to FOIL it by hand, but I'll still put it down. That, again, is just that middle term has to be doubled. That's why that's 2. And if it's negative, it's the same idea, times itself. And then it would be minus in the middle. But then at the end here, negative times negative is positive here. If I have the sum and difference, I have 1 plus, 1 minus, then what happened is the middle term got canceled out and made 0. So the result is just A squared minus B squared. No middle term here got canceled out. But notice that's definitely a negative B because one's plus and one B is minus. All right, that's called the difference of, let me write that down here. That's called the difference, subtraction is the word difference, of 2 squares. So 2 squares, and the difference is the subtraction of them. All right, let's do some, well, actually, before we do any examples, let me just answer a question that some people may have had, and that is like, wouldn't this just be like if I had x plus 6 squared? A lot of people might think, isn't that answer going to just be just by squaring the x and squaring the 6? And isn't that the answer? Well, it's not, because as we found out, that what this really means is x plus 6 times itself, which requires us to do our first, our outer, our inner, and our last. And at the end of doing that, we got this. And that was our final answer. So it's not just by, like, this square doesn't just apply here and apply here. It would if this was a multiplication sign. But if it's an addition in between there, we have to do distributive property, like the whole FOIL scenario. So this is not the answer here. Don't just square those pieces.